right, ladies and gentlemen, we're looking at 12.4, volume of prisms and cylinders. Okay. Now, when we talk about volume, that is how much can fit inside an object. Surface area is like how we wrap it, okay? Volume is how much we fit inside it. So volume as a solid is the number of cubic units contained in its interior. Volume is measured in cubic units. So if we look at a cube, all right, it's how much can fit in here. So let's draw a cube so we know what we're talking about right here. And I like to draw a cube by making a square and then making a square that slightly overlaps. I connect my vertices. It's not always 100% perfect. I like to mark that all of the sides are the same length. Okay, so that's just the sides. Cute. All right, volume congruency postulate. If two polyhedrons are congruent, then they must have the same volume. So if you have two cubes that are the same, they have to have the same volume inside. The volume of a solid, volume addition postulate. The volume of a solid is the sum of the volumes of its non-overlapping parts. So if I put two things together, right, and let's say these fit perfectly one on top of the other, the volume would be both of them added together. That's not overlapping. All right. I don't know how to pronounce this guy's name. Carvel's principle, we'll call it. If two solids have the same height and the same cross-section, remember we talked about cross-section, it's where you cut it, then they have the same value. You guys, can we put the cell phones and iPods away and be paying attention to this, please? So it shouldn't be on your desk. I shouldn't see your finger touch the screen. Thank you. All right, volume of a prism. So any of these things are prisms. Remember, prisms have two bases that match. So we have triangular prisms. We have rectangular prisms. Okay. Theirs is the volume equals the area of the base times the height. That's it. Okay. Volume of a cylinder. So cylinders are our lovely can shapes. It's simply the area of the circle, pi r squared, times height. That's all we're doing. Okay. So these are our new formulas for today. So we've got this lovely can here. We know that the volume equals pi r squared times height. So r equals, in this case it's hard to see, but I believe it's 2. And the height equals 6. Radius is 2. Height is 6.
What's after the radius square? What's that?
H for height. The H is liquid, sorry. So the volume equals pi 2 squared times 6. Okay. So I'm going to use pi, but if you use 3.14, the decimals will just be slightly off. You should have a calculator out every day, and you should be doing these with me so that when you get to your homework, you know how to do them all. So that's 2 squared times 6 gives us 75.4. Let's remember that. And that's inches what? What am I going to write? Am I going to write inches? Inches squared? Inches cubed with a 3. Okay. All right, so we've got this funny shape, and I know one of the hardest parts is figuring out what the base is. This shape looks like this. It's looking right at you. So my bases are these big squares, the tops and the bottoms. Okay? So we've got to figure out the area of these. Okay? Well, I know it's 10 by 5. So my area, my base area, is 10 times 5 gives me 50. Okay, and remember we're using volume equals the area of the base times the height. All right, and the height in this case equals 3. So that volume equals 50 times 3. So I get 150 centimeters. Why does it do that every time? 150 centimeters cubed. Huh? 10 times 5. I found the area of the base. Okay, let's turn it over. For these, we're going to have the volume and we're going to have to find a missing part. Okay. So we know for a cylinder, its volume equals pi r squared times height. Okay. My radius is 10. My height is x. And my volume is 30. Okay. So we're going to just fill it in. 30 equals pi 10 squared height. Now what do I do?
First you do pi 10 squared.
Pi 10 squared, yep. And we get 314.16. Times the height. What do I do now? Divide. My height's going to be really small. It's 0.095 centimeters equals my height. Why is this centimeters and not centimeters squared or centimeters cubed?
Because it's just the height.
It's just the height. She said.
This area.
Okay. We know the volume of a prism equals the area of the base times the height. Okay? So, and we know area of base is length times width, right? So the volume is 150. The area of my base is 10 times x. And the height is 5. So 5 times 10 gives me 'So I get 150 equals 50x, and then how do I get 50 back up? Divide. How many times does 50 go into 150? 3 times. So 3 inches equals x. How are we feeling? Okay, we're going to skip example 2 because apparently I forgot to draw pictures. And move to example 3, our story problem. All right. A common design for a swimming pool is for the depth to change gradually from the shallow end to the deep end. Use the dimension shown. Oh, I didn't draw a picture for this one either. All right, we won't worry about it. This one looks very similar to one that will be for your homework anyways. So maybe we'll look at that. We'll look at see what kind of story problems you have for your homework. Okay. So your homework for tonight is page 822. And it is problems 4 through 28 even. So problem 4 and 6, you're going to have to find the volume of 2 parts and then add them together. Okay? We didn't do one like that. 8, we did 10 and 12. I'm not sure why we're talking because I'm still recording and still talking. 14, you're going to have to sketch what it is before you find the volume, but it shouldn't be that bad. 16 is a triangular prism, so you're going to have to use 1/2 base times height to find the base. 20, you're going to have to add things together. 18, you're going to have to take away something. 22, you're going to have to find the height. 24 and 26 are not right prisms. And then 28, yeah, you'll be okay with all of these. Some of them you're going to have to take away or add things to it. So if I gave you something like, if I gave you one box, but then added a second part to it, right? You would have to find the volume of both of them and then add them together. Okay? That's a lot like the homework. And there is some homework where you're like given a cylinder, and then I'm telling you there's another cylinder inside that cylinder that you have to take away from it. So you just find the volume of both cylinders and then subtract. So if something is next to something, you add. If you're taking something away, obviously you subtract. Okay? All right, please take out your writing notebook. We are going to read.